to create rectangle function. And then it shows us the call to create rectangle here and how we can add white and black so that the square is filled with white and outlined with black. And then it gives us the idea that we should use for loops to create our row. All right. So now let's talk about matching. And before we get into coding, I just do want to point out in terms of what we put in the chat, definitely answer my questions that I have. Um, Type any answers that you have, but try really hard not to copy and paste entire blocks of code, because we want to work through the problem together. We want to give everyone an opportunity to contribute to our solution rather than just everyone kind of sharing the solution that they've already implemented. So, that being said, have we solved something similar to this before? And what CS concepts help us with repeated actions? Go ahead and throw your answers in the chat. The second question, we might have given it away a little bit in the problem statement. Yeah. So someone answered that a CS concept that we can use to help us repeat actions is for/while loops. That's a really good point. We'll definitely be using those. And then some problems that we might have done that have solved something similar might be previous graphic problems this week or any problems that we used for and while loops before. Okay, so let's move into the planning phase. This is something we want to think about maybe before we start coding, right? And we know that it starts at x equals 0. I want to propose to you guys if the first box starts at x equals 0 and the second box is right on the other side of the first box, where should the second box start? We can look at the graphic as well. Yeah, exactly. So our first box, if it starts at x equals 0, let's try doing there we go. It starts at x equals 0. And then the second box is going to start at whatever the size of the box is, right? And then, oh, Kevin also said 1/5 the size of the canvas. That's also a way to calculate it. But yeah, so there's definitely different solutions to this problem. But let's think about it for now as the width of the box, right? And then how about the second box? Where does it start? Or sorry, how about the third box? Where does it start? So we have 0, width of the box, and then where does the third box start? We just add the width of the box again, right? So does anyone see a pattern here? So this is 0. This is the width of the box. 2 times the width of the box. 3 times the width of the box. 4 times the width of the box. Does anyone see a pattern developing here? So one thing we can do in our planning phase, okay, let's see, how do I get rid of clear all drawings? Cool. Um, so in our planning phase, we can kind of write and it might inform how we actually approach the problem. So we have I equals 0. So on our first box, left x is gonna be 0. On I equals 1, left x is going to be the width of the box. 2, it's going to be 2 times the width of the box. 3, it's going to be 3 times the width of the box. So we can see ourselves doing something over and over and maybe using I with that. So let's actually get started coding here. All right. So let's get started. Um, let's first just draw a singular box and see how that goes. And then we can kind of think about the problem-solving strategy that we have already kind of talked about. So we have here that we can call the function create a rectangle. Okay, if I want to create one box, it seems like I'm just going to use that, right? So I'm just going to copy and paste that into my IDE. And something interesting, if you guys haven't learned this, I learned this way too late in my coding career. But at least on Mac, you can press Command and then the right bracket to move things over all at once. Um, and I'm sure there's an equivalent command on Windows as well. But yeah, let's create our first box. So for our first box, what did we say our left X was going to be? 0. Right. All right. So how about our top Y? We haven't talked about this quite yet, but recall that up here is going to be Y equals 0, right? This was a little bit confusing to me getting started as well. So if Y equals 0, okay, let's try the height of the canvas. Canvas height. All right. Okay, it seems like someone else is saying canvas height minus box size. So let's see if we can maybe think about this a little bit. So our canvas height is going to be this right here, right? Here, and this is going to be 0. So we're trying to figure out what the height or the top Y is going to be. So the top of our box. So our box is going to be drawn here. And this is going to be what value? Box size, right? So I agree. It's going to be canvas height, which was this, box size, and that's going to be our top Y coordinate. All right. Nope, box size. All right, so then our right X is going to be what? And this is the same as our left X for our second box, right? Yep, box size. And then bottom Y is going to be the canvas size because it's this value right here, right? We start at 0 and we go to canvas size, which is at the very bottom, or canvas height. Okay, awesome. So what I did here is declare variables for our coordinates of our box. And it's always good to add comments to your code as well, so you know what you're doing where, and so that people can read it as well. And then we're going to draw the box. Awesome. Draw a box. Cool. So let's run it. Oh, looks like I misjudged via my drawing where it was going to end up. But okay, awesome. That looks like a box. Cool. All right, so in terms of next steps, we've done one part of the problem. We've broken it down. We're able to draw one box. Um, what Python tool did we say we were going to use to repeat something over and over again? A for loop. Yep, exactly. So I know I'm going to draw boxes over and over again, right? So let's go ahead and take all this code that we had and stick it in a for loop. Okay, so the first thing we want to think about in a for loop is how many times do we want to do something? So for I in range, how many, what are we doing in this for loop? What are we using it to do? We're drawing a box, right? So we want to think about how many boxes we want to actually draw. And that's given to us, right? As you guys learned, I think a bit early on, these things up here are constant. So we don't ever want to change these within our code. So that's something to think about as well. But we can say for I in range in boxes. Awesome. Okay. So now we're gonna draw a box 5 times. Do you guys think this is gonna work if I run it? are we going to have this beautiful picture that we want? No, we do not. We do not. So maybe we should go back to our plan and think about, oops, that was pyramid. And think about how we planned to draw the first, second, and third box. We said that the first box is going to have a left X of 0, right? And then we said we can use the number of box that we're on, or in a for loops case, what counts the number of boxes that we're on here? How are we tracking how many boxes we've drawn in our for loop? I, exactly. So when we say for I in range and boxes, I is starting at 0 and then running through the loop. And then it's I is 1, then we'll run through the loop again, all the way up to n boxes, right? So if I is 0, then we want the left X to be 0, correct? If I is 2, we want it to be box size. If I is 3, we want it to be box size times 2, etc., etc. So how should we calculate what our left X is going to be? Does anyone have any ideas based on our plan that we drew out? Box size times I, that's a really good idea. So I kind of thought of it as we're adding to it each time, right? So it starts at 0 and then we're adding box size times whatever box we're on. And then I realized, hey, adding 0 does nothing. So let's go ahead and simplify it here. All right, for top Y, are we changing that when we go through the loop, or does that stay consistent through each loop? Yep, consistent. All right, now how about right X? We could think about right X independently, or we could think about what do we have already set that will easily let us figure out what right X is. Box size, yep, we could definitely calculate it with box size. Yeah, so there's a couple ways we could do it. We know that left X plus whatever the box size is going to give us the other side of the box, right? Otherwise, if we didn't want to use left X, how could we calculate it? What would we multiply it by instead of I? I plus 1, exactly. All right, and then how about bottom Y? Does that change? Exactly. All right, should I run it? Let's run it. Okay, it's looking pretty good. Let's see if it's right. All right, awesome. So if we had more time here and the pyramid problem wasn't as long, I would spend some time thinking about how could we maybe break this down easier? How could we make this more readable? But honestly, I think we did a pretty good job at keeping this in a readable way. Um, and we also made sure to use our constants. One mistake to make, or that a lot of people make when they're starting out coding, is hard coding numbers. So, for example, that would be I see that there's 5 boxes here, and I would say, hey, this should be in range 5, right? It's gonna work, but if someone were to go to my program and say, oh, I actually want, this number of boxes, it would still make 5 boxes. So we always want to use the constants that are given to us so that we don't create any confusing behavior like hard coding numbers that shouldn't or should be able to change if we change a constant or a variable, for example. All right, great. let's keep on moving. Okay, I'm gonna stop sharing for 1 second because I realized that my pyramid solution, some of it was already in there. So I'm gonna take that out and then I'm gonna share my screen again. Great. Okay, so we're going to go through the same problem solving process we went through with um, our previous problem. So let's first understand the problem. Um, I explain this a lot in my section leader training sessions, but for me as a beginner programmer, sometimes it's really difficult during section because I'm kind of a slow reader, and so I would not fully understand the problem. And then we get to the part where we're, planning and then coding, and I would feel already behind from the understand step. So if you find yourself in that position, reread it over and over, maybe take notes on it. See if there's important stuff that you can pull out from the problem. Understanding it is a really important first step, before you actually are able to, approach the problem at all. So let's understand this. Write a program that draws a pyramid consisting of bricks arranged in horizontal rows so that the number of bricks in each row decreases by one as you move up the pyramid. A sample run is shown below. The pyramid should be centered at the bottom of the drawing canvas and should use constants for the following values: brick width, brick height, bricks and base. You should write your program so that if the constant values were different, the pyramid drawn would reflect those values in those constants, aka what I just said, not hard coding values in, or putting like raw numbers like 14 in because we know that the base is 14, or maybe not writing create rectangle 14 separate times because that won't work if we are given different numbers for our constants, right? Bricks can be any color you like. Here's an example with a single yellow brick in the top left corner of the canvas. All right, so now let's move into match. Have we solved something similar like this before? And what CS concept help us repeat actions? I'm going to give you a hint. Have we solved something similar to this before? Think very, very recently in your brain. Just something that might be helpful to us. Yeah, box row. So we can think about how we approach that problem, and we can get that to help inform how we approach this. All right, so for our plan step here, I want us to think about how can we break this problem down into smaller problems. The entire pyramid is pretty daunting, right? We have rows and we have different numbers of boxes per row, etc. But we want to think about the problem in a way where we can make it approachable to us, right? So does anyone have any ideas on how to break down the problem into smaller problem? Yeah, this is a good idea. Working with like half the canvas, that can help us think about the problem for sure. We might use that later. Rows and columns. Okay. Do first row. I love this idea. So let's build the base of the pyramid and then go from there. And that kind of helps us think about the problem in rows as well, right? All right. So first, instead of trying to do everything at once, let's just start by creating the base of the pyramid. Awesome. So we have built rectangles a couple of times now. So we can use and this is where the matching comes into place as well. We can say, hey, we did this code before, so maybe we can reuse it in this problem. So here we're drawing a box, right? The reason I'm copying and pasting this over, this and this create rectangle function down here are the same exact thing. I understand functions a lot better when the variables have names. So we have left X, top Y, right X, bottom Y, and then our colors. Whereas here, we're doing the exact same thing. We're still giving it the same information. Remember, a variable is just something that stores information, right? But here we're giving it just the value zeros, for example, for our left X and our top Y. As a reader of the program, I don't really know what we're giving it, right? So I'm going to stick with using variables and filling those in. Um, so that I can know exactly what I'm giving in which spot to my function, if that makes sense. All right, cool. So let's do, or let's create a rectangle. All right, why is it yelling at me here? Because I haven't defined these variables yet, right? So let's define all these variables and let's just start out by drawing the a yellow brick in the top left corner as we're doing down here. So our left X is going to equal 0. Our top Y is going to equal, what is it going to equal? If I want to be in the top left-hand corner, our top Y, so our very top of the box, 0. Yeah. And we can always refer back to our trusty graphics review where we can see that 0, 0 is going to be the top left corner. All right. I'll go ahead and exit out of box row so I don't keep clicking into it on accident. Um, right X is going to equal, what's it going to equal? Remember, I'm just drawing a box. Yep, box width. And then bottom Y. And thank you guys so much for not posting all of your code into the chat. We really appreciate that. This is creating such a good problem-solving session. Yeah, brick height. And if it's helpful to you guys can always draw this out and label where everything is, maybe even create kind of a grid where you can see where each of the things kind of land. And that might help you visualize this a bit better. But speaking of visualizing, we can always run our code to see what we've done. Okay, cool. So I drew a box, but I didn't actually make it yellow. So instead of making it white, let's make it yellow. Cool. Okay, awesome. So we have our box. And before we try to do it over and over again, which is what we're going to end up doing, let's think about where we want our very first box to end up on the screen. And this is like kind of one of the trickiest parts of the problem. But the way that we can think about it is we can look at our pyramid and we can say, hey, how can I calculate where the left X is going to be of the first box? If you want to think about how to calculate something, you might want to start by labeling what you already know. So we're trying to figure out what this coordinate is, right? Left X. We have our canvas width just given to us. And then imagine we also have our row width. So the width from here to here. If we had our row width and our canvas width, how could we figure out our left X? Yeah, that's a really good point. If we, since the number of bricks changes every row, we might need to think about how we calculate the row width for sure. But just imagine for this hypothetical that we know our row width, that we're given it. Okay, so we have a couple of suggestions in the chat. Great, guys. All right, let's try a suggestion. So let me clear my drawings. All right, cool. Some really awesome suggestions here. Okay, so we're gonna try to draw this at our right spot, right? So let's try one of the suggestions here. Um, this says canvas width minus parentheses brick width times number of bricks. So here it's going to be bricks in base, right? Divided by 2. And we want a parentheses around our canvas width and here. All right, so looks like we don't quite have it, but at this point, I'm not sure if it's because we don't have our left X right, or it's because we don't have our right X right, right? So let's go ahead and update our other values to make sure they are correct, and then we can revisit our left X. Okay, so our top Y, what is that going to be if we want it on the bottom row? Canvas height minus brick height. Yep, kind of just like we did before for the box row problem. Cool. And then our right X, let's just stick with our trusty left X plus, what do we add to left X to get the right X? Brick width. Yep. Awesome. And then our bottom Y, just at the bottom of the page or our canvas. So is it going to be 0? It's at the bottom. Sounds right to me. Oh, that doesn't seem right. Canvas height, right? Because the bottom and the top are flipped on this, which is very confusing. All right, cool. Okay, so we have a box. So our line of code here is a little bit confusing to me. Because we not that it's wrong, it might be right, we'll see. Because we talked about row width here. And as someone talked about earlier, row width might change or will change depending on what row we're at. So let's calculate row width and then use that to calculate our left X. So let's say row width, if I can type. How are we going to calculate row width? And by row width, I mean from here to here. Brick width times number of bricks, right? All right. Do we have number of bricks or are we using bricks and base right now? We're using bricks and base right now. Okay, cool. So that is literally just this value, right? So that this line is a little bit less confusing to us, let's replace this with row width. All right, so now we have our left X is canvas height minus row width divided by 2. And I think we can delete some of these, or this set of parentheses, right? Because we don't have anything within, we just have one thing within those. Okay. Is this looking right to you guys? Does this seem like it matches up with kind of what we saw here? Okay. So we landed on canvas width minus row width divided by 2. All right, so we have canvas width, and then we subtract the row width, right? So then at that point, if we do canvas width minus row width, all we have left is what's over here and what's over here, right? And then we divide it by 2. Sounds like we get left X. All right, so let's stick with that for now. We can always revisit it if it doesn't work out. All right, cool. So, all right, now we're here. Now we have one block. So we have a start. Yeah, exactly. We have our starting point for our first row. So let's kind of approach it the way that we approached our box row problem by